Hello everyone, today I will be showing you how to balance basic chemistry equations. So let's get started. On the screen we'll see that we have an equation C4H10 plus O2 yields CO2 plus H2O. So what we want to do first is look at the left side equation and find our biggest compound, which is C4H10. We then want to look on the right side of the equation to see what components we have to match up with the C4H10, and we see that we have a H2O with a single oxygen and CO2 with two oxygens. This means that we have to double whichever one has the odd amount of oxygen. In this case is H2O. So if we did not double it, we would only want 5 H2Os to match up with the 10 H's on the left side of the equation in C4H10. But since we want to double it to make this oxygen an even number, we want to have 10 H2Os. So now that we have 10 H2Os, we also have 20 H's. So now we have 20 H's, and on the left side of the equation we said we only have 10 H's. So now we need a double C4H10, so put a 2 right there. We can now count up our carbons. We have 8 on the left side, and we only have 1 on the right side, which now means we need 8 carbons here. Now we can count up all of our oxygens. So we have 10 from our water, we have 16 from our carbon dioxide. Add those up, we get 26 oxygens. Only 2 oxygen on this side, so 2 times 13 is 26 oxygens on both sides. So now we can check our work. We have 8 on the left, we have 8 on the right. For our oxygens, we have 26 on the left and 26 on the right. And for our hydrogens, we have 20 on the left and 20 on the right. Everything adds up. This equation is balanced. Now for our second equation, we have BaOH2 plus Na2SO4 yields BaSO4 plus NaOH. So first we're going to examine what kind of compounds we have here. We see we have one Ba on the left and we have one Ba on the right, so that checks out. We have 2 OHs or 2 hydroxides on the left, and we only have 1 hydroxide on the right side of the equation. So automatically we know we need 2 NaOHs. So now we have 2 NAs on the right, we have 2 NAs on the left, and now finally we see we have 1 SO4 on the left and 1 SO4 on the right. So we can check real quick, all these will be 1. So we have Ba is 1 to 1. Our OHs, we are 2 to 2. Our NAs, we are 2 to 2. And our SO4s, we are 1 to 1. This equation is now balanced. Now for our final equation. This one might seem a little complicated, but I promise you it is as simple as any of the other ones. So first, again, we're going to examine what kind of compounds and elements we have. We see we have 2 ClO3s on the left side, and we have only 1 on the right side. But we also see that we have 3 Lis on the left side and only 1 on the right side. So first we want to balance our Lis. So we see we have 3 Lis on the left and only 1 on the right, but we can't have 3 Lis on the right because that will make us only have 3 ClO3s here, which will not balance with the 2 we have on the left side. So what we have to do, remember what I said in the first equation, we're going to double whatever we would need. We need a 6 here. We would need a 2 here. We now have 2 PO4s. Now we have 6 Lis. And now we can balance our last one. This one looks good. We can take a 3 here. 3 times 2 is 6. We have 6 ClO3s. And we'll have 3 Cas, 3 calciums. Now let's do our check for Li. We are 6 to 6, left and right. For our PO4s, we have 2 on the left, 2 on the right. For our calciums, we have 3 on the left and 3 on the right. And for our ClO3s, we are 6 on the left and 6 on the right. This equation is now balanced. as simple as any other ones. Thank you all for watching. I hope this would help some of you, and enjoy your day.